probably review what we did last week. We talked rational functions. We talked simplifying, multiplying, and dividing. This week, we're going to talk about adding and subtracting and then solving. So there's one simplify, there's one multiply, there's one divide. And really, as you build from this, we start with simplify, and then every operation includes simplify after that, okay? Simplifying this doesn't really go away, but let's see what we can get from this. So simplification requires us to factor, okay? So we deal with the numerators and denominators like their own thing. So we're going to common factor first. So these have a 2x in common. And that's going to leave me x minus 4. I'm sorry. X minus 2. And then the bottom, so the top up here, this was a common factor. The bottom down here, we're going to, it's not a common factor, 3 terms, so you learn this with the box. But this is going to be x plus 1, x minus 2. If you watched my video on simplification from last week, I talk about factoring these things with factoring quadratics that have 1 as the first term, where you can just look at the last number. It might be helpful to rewatch that again on that simplification. Help you out doing that a little bit quicker. But anyway, so here we see with the simplification, this x minus 2 will cancel out. And that leaves us 2x over x plus 1. Nothing else cancels. That's the lowest term for that fraction. Now we come in here and start on number 2. We want to multiply these fractions, but before we do this, we always want to simplify first. So that means we need to factor and cancel just like we did over here. So we've got x plus 3. The bottom of this has a common factor of 5. So that's x plus 1. These two are quadratics, and we're going to need to use the box to factor those. But since the lead coefficient's 1, we're looking for the factors of 2 that add together to 3. I'll read it from the back forward. 2 added together to give you 3. So that's going to be plus 1 and plus 2. The lead coefficient is 1 again on this quadratic, so it means we can read it from the back. We're looking for the factors of 3 that add together to 4. So that's going to be 1 and 3. That's plus 1 and plus 3. And now let's cancel the things that are the same in each. So that's going to cancel. Nothing in this one. Now, since I'm going to multiply this, really this thing isn't 2 fractions. It's really 1. So if you don't want to rewrite this again, what you can do is say, because of this multiplication, this is more like this is one big fraction right here. Okay? So since this is one big fraction, we need to cancel the x plus 3 as well. And we end up with x plus 2 over 5, x plus 1.
I follow. All magic is based on that.
Everybody good with that one? I wish the video was on my recording right now. For number 3, this is the division. And I put this one in here. It looks ugly this way because it's a division. It's 2 fractions with a division bar in there, but rewrite it the way that you would be more accustomed to seeing it. And with this one, this is the one that we'll probably miss more often when it gets thrown in there. There's no pluses or minuses joining any of these things. It's all multiplication. So I can cancel like terms on top and bottom of each one of these fractions. So this x cancels one of those. These two y's will cancel two of those. Nothing divides out between 2 and 3. No common factors. No common factors for 5 and 6. But this x cancels one of those. So that means when we go through and we simplify first, we end up with 2x to the third y over 3 divided by 5x over 6. But because there's no, like up in here, we had pluses and minuses that messied this up and made us have to factor it. Here, everything here is just being multiplied together. So we can just cancel without having to do any extra work with each numerator and denominator. But now we need to follow our rule, which was we're going to change this to multiplication and flip this over. And it helps if I write the right number down here. 3. And then we're going to combine all of this stuff together. So 2 times 6 is 12. We get x to the third y 15 over x. Multiply the coefficients, combine the powers of any of the exponents that are there, but we don't have any. So now we need to simplify the 12 over 15. That has a 3 in common. So that's going to be 4 over 5. Then the x in the bottom cancels 1 out of the top. So that leaves us with x squared in the top, and nothing affects the y. So that's it. We're done with that one. Now, we spent a good bit of time on this last week, and I think you guys have it down pretty well. But as we start adding and subtracting, we tend to get the rules confused. So do be cautious, because the beginning of this week, we started yesterday and today, we're going to talk about adding and subtracting our rational expressions now. Okay, so this is going to be new for this week. So we're still dealing with rational expressions like these. But now we want to add and subtract them, which is a little bit different. So let's look at this as if we're dealing with numbers first, see if we can remember what we need to do. So if I had 2/3 plus 1/5, anybody remember what you need to do to make it so you can add those? You got to find a common denominator, right? And you want to try to find the least common denominator. And with rational expressions, that gets a little bit tough. But normally what you would do, like with this one, you take this 5 and you multiply it on the top and the bottom of this one. You take this 3, you multiply it on the top and the bottom here. So we'd get 5 times 2 over 5 times 3 plus 1 times 3 over 5 times 3. So that's 10 over 15 plus 3 over 15. And what it is because the bottom is the same, I can write this as one fraction with just that in the denominator, and then 10 plus 3 on the top. Because I have 10/15ths of something and 3/15ths of something, it's almost like if I create the same denominator, they're divided into the same pieces, they fit in the same container. So therefore, I can just put the tops together. So this ends up being 13 over 15. We're going to do the same thing with our rational expressions. It's just going to look a little bit different. And factoring before you start is going to be huge with this to make this as easy as possible. So when we go to add and subtract rational functions, factor, 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 factor. Factor each fraction, get rid of anything that's the same in the top and the bottom, just like we did with multiplying, dividing. Get common denominators. Remember that whatever you do to make the denominators common, whatever you do on the bottom, you're going to need to do on the top. You're always going to be multiplying the denominators by something to make them the same. Whatever that multiplication is on the bottom, you have to do it on the top to keep equality. Add or subtract the top, depending on which operation, keep the bottom. Once you get done, you get down to one fraction. You got to make sure you factor and cancel anything again. Sometimes with what you have left, it's not going to factor again. Nothing's going to cancel, but you do need to at least check it because sometimes it will. So let's work on a couple of these. So we're going to start with, this was Monday, okay? We're going to start with some that are the same denominator because that makes it a little bit easier just to go through the process. And then we're going to work these because I think this is where we need to practice, these ones that don't have the same denominator with them, and we'll go from there. This is not supposed to be here like this. Quick edit, sorry. So when you go through your steps, first thing it says to do is factor. There's nothing I can do to factor the tops of these two fractions, meaning that nothing's going to cancel. Because I'd have to have a plus or minus there. The second step says to get common denominators, but these two denominators are already the same thing. So what that means is, since they're already the same, I can write this as one fraction with just that single denominator. One of the most common errors is that you write them down there twice like they're being multiplied. But it's really just, it's going to be the same. So you only need to write it once in the bottom. And then we're going to, because this is subtraction, we need to preserve this order. So this is going to be 7x minus 49. Now we need to look to factor again. 7x and 49 have a common denominator or common factor. It's going to be 7, which will leave you x minus 7. That's x minus 7. And now we have a common factor in the top and the bottom that'll cancel. And our answer is just 7. Which is interesting because it means no matter what x you plug into this, you'll always just get the number 7 out. Any x you plug into this one. But really, we're focusing on the process here. Same, get the common denominator, and then just either add or subtract the top. Now, the second two are the ones that we probably need to focus on a little bit more. Ones that we don't have common denominators in the bottom, okay? Because that's going to be a little bit tougher for us to deal with. So let's look at this first. So before we even start worrying about common denominators, we need to factor each fraction independently. So the top has a x in common, which is going to leave me x minus 4. The bottom has a 3 in common. Two x minus 3 doesn't have anything in common. So it's just 2x minus 3 in there. And then x minus 9 has nothing. Now this is where sometimes our factoring doesn't pay off because we may have to undo that later on. But does anything cancel in either one of these fractions? Nothing cancels, right? There's nothing the same in the top and the bottom. We didn't get any results out of this. But by factoring the denominator, sometimes it makes it a little bit easier to see what we need to do. But we're going to tackle this just like we did the numbers. We're going to take all of this and multiply the top and the bottom over here by. We're going to take all of the second denominator and multiply the top on the bottom by. And it's going to get a little bit messy as we work through it. So we had 3x minus 3 and this x minus 4. And this was 2x minus 3, x minus 9. And what we're going to do is we're going to take this x minus 9 and we're going to write it over here. Top and bottom. Then we're going to take both of these things, the 3 and the x minus 3, and write them here. Now, even though this is intimidating to look at because there's a lot of terms in here, we've satisfied what we wanted. We wanted the denominators to be the same thing. Are the denominators the same thing? They are. And that's our ultimate goal when performing this operation. So we can write this as one fraction. And I'm going to put the 3 up front just because it doesn't matter what order I multiply in. But now I need to do this plus on the top. So I have this x minus 9, x minus 4 plus 2x minus 3, there's a 3 in front. And part of the reason I'm working with this messy one to start, right off the bat at this point, I see a lot of people get really tempted to try to cancel this x minus 9 and this x minus 3, but you can't do that because these things have a plus in front of them, okay? So at this point, what we need to do is we need to deal with this stuff on the top. We need to simplify this. What I want you to do is I want you to forget this is a fraction, okay? Because I think rewriting the fraction bar constantly sometimes makes this tougher than it needs to be. Write this off to the side somewhere. So we had x minus 9, x minus 3, right? X minus 4, I'm sorry. Plus 3 times 2x minus 3. X minus 3. I need to do this operation and simplify this in the numerator first. I need to add these things together. There's no need for me to write the stuff on the bottom and deal with that until I've dealt with the top. You could write this off to the side, treat this like a normal problem you know how to deal with without the fraction. So we got to multiply all this out and see what we get. So let's see, we get x. This is going to be x squared minus 13x plus 36. There's a 3, so this is 2x squared minus 9x plus 9. Now we've got to put the x in there. We get x to the third. This is 6x squared, 27 and 27. Right, so we're just multiplying out, and now we need to combine like terms. So we've got a minus 13 and a plus 6, so that's going to be minus 7x squared. 36 and 27 is going to leave us 9. Then we get 27. So that means all the top turns into that. So right here, we ended up with x to the third minus 7x squared plus 9x plus 27. And it's still over that stuff. Now we are left with a little bit of a bind in this one because we've got something with a bigger than a power of 2 on top, which you probably won't have to deal with often, but you could. And we need to know if it factors. But more importantly, what we need to know is we need to know if x minus 3 or x minus 9 are factors. So we've got to think back to our polynomial unit. How do we figure out are x minus 3 or x minus 9 factors? And if you think back, this is where we did the polynomial division. So you can always check it with polynomial division. Now, in honors, we learned how to do synthetic division to determine factors. That was much easier. The other way you could do this, though, you can plug that into Desmos and see if it crosses the x-axis at +3 or +9, and you know that it would be a factor, and then you could divide it afterwards. But if we use synthetic division, we can check each one of these pretty quickly. So the coefficients are 1, -7, 9, and 27, and we'll see if this comes out. That's 1, that's 3, -4, -12, -3. That doesn't work, right? So that's not a factor. Then we can check 9 to see if it's a factor. One, 9, 2, 18, 27. That's not going to work, right? Because this is going to be big. So all you'd need to do is just double check that it doesn't factor. You shouldn't end up with stuff that's bigger than squared, but if you do, you can always check with your polynomial division to see if it works. If nothing is a factor, then this should be all we have to deal with. That would probably be the most complex one you'd have to try to factor. Normally, you're going to end up with something squared at the worst, but there is a way to deal with that. All right, let's try one more. See if it's a little bit pretty. What's the first step? First step is factor. So nothing factors out of our first fraction. Nothing factors out of the numerator. Factors of 27 that add to 6. I'm sorry, let's subtract to 6. That's 9 and 3. So that's going to be x minus 3, x plus 9. And there's the common factor here. And now this got a whole lot easier to deal with because we no longer have a quadratic in the bottom. So there's your importance of factoring first, because this is one that have gotten to the third or bigger powers when we go to multiply the denominators. But by factoring, now we're not going to have anything bigger than a quadratic. So we're going to take everything from the second denominator and multiply it in front here. Everything from the first denominator, multiply here. So we end up with, we've got 2x and x plus 3, 1, and x plus 9. And this is going to get the x plus 9 on the top and the bottom. This is going to get the x plus 3 on the top and the bottom. Don't worry about multiplying out your denominator because you want your fractions to stay factored. The top is the only part we need to worry about multiplying out and then factoring again. So this is going to turn into one fraction with x plus 9, x plus 3 on the bottom. And now I need to deal with this operation. This is going to be 2x, x plus 9, plus 1 times 2x. So it's this one plus, I'm sorry, not 2x, plus 3. I apologize. And just like the last one, we just need to clean up the top and then see if there's any common factors from the bottom that'll cancel out. So we need to multiply this across. So 2x times x is going to give you 2x squared. 2x times 9 is going to give us 18x. And then we're going to get plus x and plus 3. So the top of this is really 2x squared plus 19x plus 3. And once you get here, you just need to look at the top and figure out, does this factor? I don't need to really highlight it. So does the top factor? So we gotta, this is a quadratic, so we gotta look at the box. So we've got 2 times 6. I'm sorry, 2 times 3, which is 6. Are there any factors of 6 that will ever add up to 19? So that means it's not going to factor nicely, which is what we want. We don't care about the imaginary or the irrational roots. We want it to be either 9 or 3, so something cancels. So since that's not going to factor nice, we're done.